Hello everyone, welcome to QSS Lecture 1, Fundamental Math. And today we're going to be talking about probability and linear algebra. So let's start with some linear algebra fundamentals first. And so what we'll be covering today are scalars, vectors, matrices, operations with vectors, matrix operations, and practical applications in quantum mechanics. So scalars. So scalars is just the magnitude of something. So whatever you're measuring, such as speed, you're going 30 miles per hour, 60 miles per hour. Distance, it's 5 kilometers away. You're not saying it's 5 kilometers north. You don't mention direction with scalars. And the types that are used specifically in quantum computing are real numbers and complex numbers. And we'll talk about these complex number operations in later lectures. And vectors. Now vectors are scalars with direction. It's the magnitude with direction. So the representation in 2D can be, x comma y being different number parameters, or x comma y comma z for 3D. And the magnitude is this formula. The magnitude of a vector is the square root of the two numbers squared, and you add it together. And some key properties are unit vectors in quantum computing. That's x squared plus y squared equals 1, so that's another formula. And some common examples of vectors are force, velocity being speed, which is a scalar with direction, and acceleration. And qubits are also represented as 2D unit vectors. Alright, so some common vector operations. So for addition and subtraction, we have the commutative property and the associative property. You'll just do that like how you do it in regular math. And then scalar multiplication. So if you're multiplying 5 with your 3D component, for example, 4 comma 6 comma 2, you multiply 5 with each number, 5 times 4, 5 times 6, 5 times 2, excuse me, and you get 20 comma 30 comma 10 as your resulting vector. And for dot product operations, let's look at this example right here. Imagine you have two vectors, x comma y and a comma b, and so if you multiply x comma y dot a comma b, the formula will be you multiply each. So xa times xb plus ya times yb. And the geometric meaning can also be you take the magnitude of each vector and you multiply it along with multiplying it with cos theta, and theta being the angle between the two vectors. And then cross product, same, you take the magnitude and you multiply with sine theta. Now let's talk about matrices. So, and matrices are arrays of numbers with structure, and that structure meaning it's arranged with rows and columns. And the notation is generally m times n, which is like rows times columns. So this, if we take a look at this matrix right here, this matrix right here, it has 1, 2, 3 rows and 2 columns. So it's a 3 by 2 matrix. And there are different types of matrices. There's square matrices, which has equal number of rows and columns. It can be a 2 by 2 matrix, 3 by 3 matrix, and the others are just like vectors as matrices, like 1 times n or n times 1, and n being any real number. So these are just some common matrix operations: addition, subtraction, multiplication. We can do scalar multiplication with this too, where you just, the same with the vectors, you just multiply each element with a number. Matrix multiplication and transpose. So transpose is when you switch the rows and columns. So m times n becomes n times m. So if you look back at this, you would just flip it. So just flip it in a 90-degree angle. And some practical multiplication examples are doing the dot product. If you have this one 3 by 1 matrix and another 3 by 1 matrix and you're multiplying them, you do 1 the first number, so 1 times minus 3 is minus 3, 4 times 2 is 8, 3 times 5 is 15. Just add them all together and you get 20. And now applications in quantum computing. So why are we studying these vectors, matrices? Why are we doing all this? So qubits are represented as 2D unit vectors, and we'll talk about all these different quantum terms in the later lectures. Quantum gates, they're described by unitary matrices. Quantum states, they're complex vector spaces, and measurements, in quantum, they're projections using dot products. So these are just some key takeaways from what we learned so far. So probability. We'll be talking about what is probability, combined probabilities, histograms, mean, median, and mode, and variance and standard deviation. So what is probability? I'm sure you all know this. Probability is just how likely certain events are to occur, and we see this in our daily lives. Like, what's the probability of a coin flip, like heads or tails? That's 50-50. What's the probability it'll be rain tomorrow? So it's just used in every scenario in our daily lives, and it's really important. And it's really important in quantum computing too, as because like the state of a quantum bit, which is called a qubit, is not just 0 or 1, but it's a mix of both at the same time. And we'll talk about this in lecture number 3, where we describe the Schrodinger's cat experiment. And so this mix is just described using probabilities, and it tells us how likely the qubit is to collapse to 0 or 1 when we check it. So quantum algorithms work by carefully adjusting these probabilities so that the correct answer has the highest chance of appearing. So probability is used in the quantum realm not to give the correct answer, but increasing the likelihood of finding that right result efficiently. So combined probabilities. Let's take a few examples. So combined probability is, probability of 2 or more events to occur. You're combining the probability of those 2 events. So that's like, for example, saying, what's the probability of getting a 3 when I roll the die and a heads? So these are all like the possible outcomes of rolling a die and flipping a coin. And we see that there's total 12 possible outcomes, and there's only one event in which that occurs. So that's the combined probability would be 1 out of 12. Or the formula for combined probability is, you multiply the individual probabilities together. So landing a 3 on a die is the probability is 1 out of 6, 1 by 6. And landing a head is 1 by 2. So 1 by 6 times 1 by 2 is 1 by 12. Histograms is another way to represent probability. So number of heads, if you flip a coin 5 times, so this is just an example for the histogram that would result in that. And so we collect data and then we just represent that on a graph, and that's what a histogram is. Mean, median, and mode. So what are they? Mean is basically the average of a data set. So if we have the data set for in this example, 15 students, a mean would just be the average score. Median is the middlemost number. So what you do is you arrange the numbers in ascending order and you find the middle number. Or if there's no middle number, if you have like an even number of students, what you do is you take the middle 2 and you calculate the mean of those middle 2 numbers in the data set. And mode is just the most frequent data point that occurs in a data set. So let's take a look at this example. So we have a teacher who gave a test to a class of 15 students, and these are the scores. So calculate the mean, median, and mode. So the mean, so what you do is you just calculate the average. So you add all the numbers together and you divide by n, which is the number of students. So that would be 1320 divided by 15. So the mean test score or the average test score is 88. Median. So like I said, you sort the scores in ascending order, like it's done here, and you just cross the numbers off, and the middle number is 88. So your median is also 88. But note that the mean and median don't always have to be the same. And mode is 81 since it appears twice and all the other scores appear once. Now let's look at variance and standard deviation. Variance measures how spread out the data values are from the mean. And so it is the average of the square differences between each value and the mean, as we look at the formula over here. And standard deviation, it's just the square root of the variance, and it tells us on average how far the data values are from the mean. So it is the square root of the variance and is in the same units as the data. So here's the formula for each. You calculate variance, and for standard deviation you just square root this number. So thanks for watching this lecture, guys, on fundamental math for quantum computing. And our next lecture, lecture 2, will be on complex numbers and vector spaces. So hope to see you there next week. Thank you.